Hello, welcome to 2.5 part 2 video. Okay, so part 1, we looked at what a function is, and we looked at how you can tell whether or not a relation is a function. So here in this section, we are going to take a look at domain and range with a focus on domain. Okay, all right, so take notes. 2.5 part 2. Intro to functions. And what we're going to focus on here today is domain. Domain and range, but really domain. Okay. All right. So let's start with the definition of domain and range. Okay. So the domain are the x values. Domain is the x values. So really the input values. Okay, so maybe your function is not a function of x, but maybe it's a function of, I don't know, different letter. Okay, but let's just say x values that produce real number outputs as opposed to imaginary ones. Real number outputs. If an x value produces undefined or imaginary results or outputs, then it is not in the domain of the function. Okay, so in order for an x value to be in the domain, it cannot produce undefined or imaginary results. Okay, the range these are the y values that can be produced by the domain. Okay. All right, so here, let's take a look. Let's take a look at it graphically. All right, so let's go ahead and determine the domain and range. All right, let's take a look at this first example. Suppose that I have this graph. Okay, x-axis, y-axis. Okay, and let me go ahead and put some tick marks here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Okay, and suppose that I have a point over here, like at 2, 1, closed point. Okay, and let's suppose that I have a point over here at -3, 2. -3, 2. Okay, and suppose that my graph is made up of this line segment that goes from that point to that point. Okay. All right, so here, when I am talking about domain, then I want to know from what x value to what x value. Okay, so remember, uh, we want to start with the smallest x value. So we want to know what x values we're using to make this graph. Okay, so like clearly 1, 2, 3, 4, 5. Okay, so like clearly over here, 5 is not being used, right? 5 is not being used to make this graph, right? Okay, so the x values that are being used are, we start from the left, is this one right over here, right? All the way to this one over here. So we start from this x value. Let me use a different color so you can see it. Okay, so we are starting from this x value, and we go all the way to this x value. Okay, and so pretty much all of the domain is in here. All the x values in between there. Okay, all right, so our domain in this case are the x values starting from -3. Okay, so all of our x values, they start from -3 and they go all the way to 2. Okay, now another way to write this is by using set notation. So -3, and we'll use a bracket because it's less than equal. So right here, less than equal uses the bracket. If it said only less than, not equal, less than, then we would use a parenthesis. Okay? And then we go all the way up to 2. And here we also have a bracket because it's less than equal. Okay? These less than equals always use brackets. If it had strict less than, not equal, then we would use parentheses. Okay? All right, so that's the domain. Okay, so this is domain. The range are the y values. Okay, so it's kind of hard to see. Here, let me try to erase the red stuff. Okay, so oops. Okay, I'll draw that line back. Okay, and so here, okay, when we're talking about the range, okay, okay, all right, let me put the line back. Okay, so when we're talking about the range, now what we're talking about is the y values. So what y values are we using to make this graph? So here now, and I'll do this one in green. Okay, so y values. So the lowest y value starts from here, right? Okay, so from here, that's -1, and it goes all the way up to here. Actually, that was a 2, huh? Okay, let me just check. Yeah, that was I erased one of the markers. Hold on a second. There was a tick mark there. Okay, so let me get green. All right, so it starts from -2, and it goes all the way up to here, right? So our graph starts from this y value and goes all the way up to that y value. Okay, so our range is from -2 all the way up to 1. Okay, and I'm going to use this set notation. And again, we start with the smaller value always. So -2, and it goes all the way up to 1. Okay, so here, these points, these filled in points, make a difference. Okay, if they are not filled in, like let's say this were an open point. So let me go ahead and erase that. Okay. All right, so say it were an open point. Is that where I'm at? No, I'm at 3, -3. Okay, hold on. Okay, so say it were an open point instead. Okay, then that would change the inequality to a strict inequality like that. And when it's, I just erased the line here. Okay, so when it's like this, that means there was an open point, not a closed point. So an open point means you cannot equal that number. Okay, so you would still say -3, but then you'd have this strict inequality. And so over here, you would have not a bracket, but parentheses. Okay, and then same thing here with the range. I cannot include -2, but I start at -2, but I don't include it. So again, parentheses. Okay, so if you have open points, you'll use parentheses. And if you have closed points, you will use brackets. Okay, and always start from the smallest number, -3, to the higher number, 2. Okay, and same thing here with the y's. Start with the smaller y value, -2, go all the way up to the larger y value, 1. Okay, all right, let's take a look at another example. Okay, suppose that I have this here, this graph, and suppose it's a line, arrowheads on both ends, which means it goes on forever. So when it goes on forever like that, then here, that means all the x values, all the negatives, all the positives, all the x values are being used. So here we say all real numbers. All real numbers. And the way we do our set notation is we say from -infinity to +infinity. I think WebAssign, you don't need to put the positive for the positive infinity. Okay. And then when we look at the range, it's the same thing as well. It's all real numbers because it just goes on forever downward, forever upward. So you're going to hit all of the numbers on the y-axis number line. Okay, so here, -infinity to +infinity. Again, for the positive infinity, you can put the positive or not. Okay. All right, so, and hopefully you see the difference between these two lines. This one is a line that goes forever in both directions, whereas this one here has endpoints. Okay, one is a closed endpoint, one is an open endpoint. Okay. All right, let's take a look at another example here. And let's take a look at the parabola. Okay, and let's go ahead and draw some tick marks here. 1, 2, 3, 4. Okay, and suppose I have this parabola with the vertex over here at 0, -2, and it opens upward forever. No endpoints, it's not capped off, arrowheads on both ends. Okay, so here, the domain when we take a look at the x values that are being used, well, since this keeps getting wider and wider and wider, right, then that means all of my x values are being used. So here, it's going to be all real numbers again, all real numbers for the domain. So negative infinity to positive infinity. However, when you look at the range, it's not quite all real numbers. Okay, so it's all real numbers. We see here that it's all real numbers way up there, right? So positive infinity, sure, but we don't quite hit negative infinity or go towards negative infinity. We don't even get to -3 or -4. So here, our range, the lowest we ever get on the y values, right? These are my x values, these are my y values. The lowest I ever get is right here, -2. So that's my lowest number, okay? So it goes from -2, but it does go towards positive infinity. So that would be my range, okay? So again, remember the range are the y values. So what y values are being used? Not these down here, right? Because my graph is only here, okay? It kind of stops right here at -2, okay? But my x's are being used. All the x's are being used because this keeps getting wider and wider and wider and wider. So this x is being used, this one, this one, this one, all of them, okay? And then over here, let's take a look at this one. Let's take a look at this graph. Let's take a look at this. So suppose that I have this graph where I have sort of this invisible wall right here. Okay, so this is an invisible wall. And let's say I have this other invisible wall. Okay, so that my graph goes like this, and my graph goes like this. Okay. All right, so here, so when we take a look at what x values are being used, our domain, okay, so we see that the graph is not here anywhere along this wall. Okay, so here, our domain, everything else, all of the other x values are being used to make this graph, right? Except for this one. So your domain is all real numbers except for one. All real numbers except +1. Okay, and the way we write that with set notation is, so we have negative infinity all the way up to 1, but we cannot include 1. So we'll put a parentheses. We'll use parentheses instead of a bracket. And then we start up again, and we use this symbol to mean this together with this next set. Okay, so that describes all of this part of the graph. Now we need to describe this part of the graph, and that's using all the x values starting just past 1 all the way to positive infinity. Okay, so that's how we would write everything all the way up to here. So we stop here at 1. Together, that's the union symbol. Together with everything from just past 1 all the way that way. Okay, and the range, we're going to do the same thing. So let's take a look. We know it's all real numbers except for what? All real numbers except what y value is not being used? This one. There's our wall. Okay, so 2, except for 2. So just like the way we wrote the domain, we're going to say from negative infinity all the way to 2. Again, we're using parentheses because we cannot include two. Union, or together with, just past 2, so parentheses, no bracket, all the way to positive infinity. Okay? All right, so that's how you do domain and range using looking at it graphically. Okay? And let's take a look at another one here. Okay, so suppose that I have this graph. Okay, so suppose I have this, and suppose my graph does something like this. And then right here, we have a hole, and then I do that, right? Okay, so my domain. So we see here we're using all real numbers except for all real numbers except, all right, these go on forever. So arrowheads on the ends there. So there's this little break right here. So there's a break at 0, x equals 0. Okay. So again, whenever you have breaks like this, then it's negative infinity to that break. And then from that break to positive infinity. Okay. And then same thing with the range. Okay. Same thing with the range. We see here, this is like an invisible wall. It's just going to kind of taper off. Okay, so we have this sort of invisible wall. Okay, so we're not using 1 and we're not using anything below 0. Okay, so our lowest value is going to be this wall all the way up to 1. There's a break. And then from 1 all the way up to positive infinity. Okay, so here, you can kind of see it here. Let me draw this a little better. So here. Okay, so you can see here it's getting really close to 0, but never really getting to it. So it just kind of hovers right close to 0. So the highest number it goes, it starts starting from just above 0, and then it keeps going, and it actually skips 1, but then it starts going higher. So we see the y values that are being used start just above 0. It skips 1 and then keeps climbing. So 0 to 1, and then from 1 to infinity. Okay? All right. Let's take a look at how to find them algebraically. So that's how you find domain and range algebraically. Okay, so, graphically. So algebraically here, so what we want to do is exclude x values that make the function undefined. And we also want to exclude x values that make the function imaginary. Okay, so this is for domain. All right, so let's take a look at some examples here. You know what, before we even do that, so let me put a little note here. Okay, so domain, for the most part, will be all real numbers. except possibly when you have radicals or fractions. Okay, so that's where you have to be careful. Okay, so let's take a look. So we'll look at several examples that have fractions and radicals, and then one example where you don't. Okay, all right, so here, let's go ahead and determine the domain algebraically. All right, so this first example. So here, y equals 1 over x plus 2. Okay, so we do have a fraction or a radical. We have the fraction. Okay, so we don't want to end up with our fraction being undefined. We get undefined when the denominator is 0. Okay, so over here, we need to find out when the denominator, which is x plus 2, when this denominator equals 0. Okay, so, or you can say we don't want it to equal 0. Okay, we don't want it to equal 0. So when does that happen? Let's go ahead and solve for x. So x cannot equal -2. That's our domain. All real numbers except for -2. So our domain, I'll just write D, is all real numbers except -2. And so the way we write that is if we have exceptions, then we say -infinity to -2, and then -2 to +infinity. Okay, so whenever there's an exclusion, a number that you need to exclude, this is how you write it in set notation. Okay, let's have a look at another one. Suppose that I have this 3 over x minus 1, x plus 4. Okay, so here's the work for this one. Okay, so again, the denominator, x minus 1 times x plus 4, we don't want it to be 0. If it's 0, we end up with undefined. So when does that happen? You take each one of these, x minus 1, x plus 4, and you solve it. Okay, so add 1 on both sides. X cannot equal 1. And over here, subtract 4 on both sides. X cannot equal -4. So that's your domain. Your domain is all real numbers except for those two. All real numbers except for 1 and -4. So let's go ahead and write this in set notation. So everything except for that. So we're going to go -1 goes all the way to -4, and then we have a break because we have to exclude -4. Okay, then we can go ahead and start again, and then we have another break at 1. Okay, and then we can start again, 1, and now we can go to +infinity. Okay, so this is how you would write it in set notation if you need to exclude 2 points. Okay, so you always have this sort of break right here at these points of exclusion. All right, let's take a look at radicals. Okay, if you have something like this, square root x minus 8. So what happens here is if we take the square root of a negative number, then we end up with the imaginary result. Okay, so here, our work, whatever this is, x minus 8, we want it to be greater than or equal to 0. Okay, so that's how you set it up. You set it up so x minus 8 is greater than, or whatever it is in here, is greater than or equal to 0. That's the setup. Okay, so then solve this. X is greater than or equal to 8. That's your domain. Okay, so over here, your domain, the way we say greater than or equal to 8, okay, so we start at 8, and we can include 8 here because it's greater than or equal. We're not excluding 8. 8 is included, and it goes all the way up to positive infinity. Okay, so we have this set notation. Again, we use the bracket when we have greater than equal or less than equal. All right, and let's take a look at this one, y equals square root 3x plus 7. So this one, same thing. So we take whatever's inside and we set it greater than or equal to 0. Okay, so let's go ahead and do that. 3x plus 7 greater than or equal to 0, and solve. Okay, divide both sides by 3. Okay, oops, too far down. Okay, so that would be your domain, greater than, anything greater than or equal to negative 7/3. So our domain here, we start at negative 7/3, and we go everything larger than that. So to infinity. Okay, so these are basically your restrictions right now for your domain. Okay, so if you have fractions, okay, like these first two, they both set up like this. Okay, fraction set up where you have your denominator not equal to 0, and you solve. And radicals, square roots. We always want them to be greater than or equal to 0 from the inside. Okay, and that would be your answer. Okay, so if you don't have fractions and you don't have square roots, then you don't really have any restrictions, at least not for now. Okay, so if you have something like this, 3x cubed minus 5x squared plus 7x minus 9. If you have this, this is just a strict polynomial. Okay, we don't have any fractions. We don't have any square roots. So here we have no restrictions. So our domain is all real numbers. So negative infinity to positive infinity. Okay. All right. This is kind of an abstract topic, domain and range. So if you have any questions during this lesson, make sure you text me. Or if you want me to go in depth a little more on any of these or do more examples, just send me an email and I can create another video. Okay. There is a part 3, evaluating functions. So make sure you catch that video as well. I will see you next time.